Hello everyone, welcome back to the channel. And in my previous video I showed you how to build a modular RAG based chatbot that lets you upload PDFs and chat with them using Streamlit and LangChain. And that project worked great, but everything ran inside a single Streamlit app and including the backend logic, right? But in this video I'll show you how to build a production ready microservice based RAG chatbot where the front end and the backend are completely separated, and we'll be using Streamlit for the chat UI as always, and FastAPI as our powerful backend, and ChromaDB as a persistent vector store for storing our embedded documents. And this separation makes your app more scalable, maintainable, and API ready. And it will be perfect for your real world use cases and some future deployment. Okay, so whether you are a beginner trying to understand RAG, or a developer looking to kind of build your application in a proper architecture, this video will be for you. Okay, so let's dive into how we can structure our project. But before that, let us first understand what RAG is pretty quick. Okay, all right. So a traditional language model like GPT or LLaMA are powerful, but they have a fixed knowledge cutoff, right? That means that they can't access your private data like PDFs, reports, or any recent documents unless that knowledge is somehow provided to them at the runtime. But sometimes our LLM hallucinates a lot. Okay, so that's the problem we still have with lots of LLMs, though they are trying to solve that problem pretty quick. So that's where the RAG comes in. And RAG is a kind of framework that kind of combines two main things. One is retrieval and second is generation. It first searches through your own data like a set of PDF. You could see in the diagram that you provided a set of documents. Okay, and this retrieval part will kind of searches through your own data, and it will find the most relevant chunk based on the user's question. You could see in the diagram that in the red dotted box, user is kind of providing some documents, and in the yellow dotted box, where from that documents we are kind of creating multiple chunks as per the similarity base. Then we are converting them through the embedding model into embedded vectors. Then it will move to that blue dotted box where those vectors will be stored in our vector databases. We have multiple vector databases as Pinecone DB, we have our ChromaDB, we have Quadrant, we have 5 similarities index search, all those things. All right. So after we stored our vector embedded in vector database, now come to the generation part. Okay, let's say a user kind of given a query. You could see in the green dotted box from the right side, a user is giving a query, and this query will get into this embedding generation model because that query will be in a string format. So that string also need to be embedded first, then that embedded model will create this query embedding. Okay, then that embedded query will get into our vector database to kind of figure out as per that query which will be our relevant embedded vector from that vector store. All right, after that we'll be retrieving some relevant vector store, like some relevant embedded vector from our database. Then that will fetch into our LLM model like GPT, LLaMA, Anthropic, Gemini, whatever you want to use. Okay, then that LLM will create a more precise and more polished answer with those vector embedding. Then it will give you the answer. You could see in the green dotted box, in the below level, you could see that GPT or this LLM is kind of providing an answer to the user. Okay, so this would be a basic working of how RAG works. Okay, so now that we understood about our RAG, this thing is, now let us understand how our application would work and is would work. Okay, so we have designed the project using a microservice architecture, meaning our front end and back end are separated into two independent modules. Okay, So we have a front end which of Streamlit UI where user would interact with, and it will have a sidebar to upload PDFs, and I'll be giving you the demo pretty quick. Okay, so before that, just let us tell you how our project would work. So you could see in the left side we have user uploads PDF, then every PDF is sent to the backend. Then we have PDF stored permanently in a local folder. Then we'll be using text splitter to break each and every document into multiple chunks. Okay, then into this vector embedding generated, so we'll be generating vector embed from those chunks. Then we'll be storing them into our ChromaDB. Then user will submit the query, then relevant chunk will be retrieved, then chunk will be passed to an LLM. Then as per the context awareness of LLM, it will generate a proper response with a Polish structure. Okay, so then that answer need to be displayed on the chat UI. Then finally you'd have a kind of an option to download your chat history. Okay, and to tell you and to kind of explain you better how the whole this cycle of would work, I have created this cycle of our application of RAG based PDF chatbot. You could see from the top of this green arrow, we have user upload PDF. Then we have front end send the request to the backend. Then we have that backend process. Then we have vector store retrieval. Then LLM will generate its response. Then backend will send the request to the front end again, and it will display the front end response. All right. So I'll try to just show you this to an architecture so that we understand like what we are building, right? And I'll be giving you this PDF so that you understand what the thing is. Okay. So yeah, now let's see the demo. All right, to show you what we want to build, so this is the demo of the application of our RAG based PDF chatbot. Okay, so first let us upload some PDF over here. So let's say I'll be giving this prepared by group 11. I don't know what is this, but I want to know about this project. I want to know about this PDF. Okay, so upload PDF, and actually this, let us see what this PDF about. So if I just come into my download, you could see that this present prepared by group 11 is kind of a, actually forgot about the PDF, all right. So it's a PPT presentation for our 6th year project. Okay, so let me just ask some question about that. So name all the team members. Okay, so let's see if it can give it me. All right, so no, it's not giving me the name. It's kind of giving me the name of our acknowledgement teachers, our HOD and our coordinators. Okay, so let us ask some more precise question. What is the topic of the presentation? Okay, all right, so let us ask some more precisely. If you could see the PPT, could see, so the topic, so let us ask the contents. Okay, so what are the contents? See, acknowledgement introduction. As per this acknowledgement introduction, survey of the previous work, scope of the work and roadmap, all these things. Okay, and let us upload some other PDFs as well. This is one of my internship certificates, so upload to DB. Okay, who is the provider, and the certificate provider is Exposys Data Labs. Okay, All right, so these are the couple of example I've given you. Okay, you can try it by yourself after you will be building the application. Okay, so that's being said, now let's get to the code. All right, so we'll start with our backend part of our application. Okay, so this is the folder of my RagBot. If you can see that one of my last rag PDF chatbot video was for RagBot. Okay, so I'll create this RagBot 2.0 in this folder. Okay, so first we need to create a folder over here. I'll be naming it server. Okay, and we'll create another folder which will be client. Okay, and don't worry, I'll be giving you this client and server in a different repo. Okay, so you don't need to worry about key. We have lots of more files in this repo. Okay, so let's move into server, cd server. Okay, now the first thing we need to do that we have already activated our mynv virtual environment. Okay, so still if you don't know how to activate or create one, I'll be showing you. So readme.md to create a virtual environment, we may write the python -m venv like virtual environment with your name, which will be mynv in my case. Then we need to activate, so activate my env, right? To do that we need to run this command mynv slash scripts slash activate. All right, so we have already activated our virtual environment. Okay, now after this we need to add our requirement.txt .txt. Here you need to, okay, so here you could see we need to install FastAPI, UVCon, LangChain community, LangChain core, LangChain Groq. If you want to use OpenAI or Google Gemini, you can use LangChain Google Gemini or LangChain OpenAI as per your wish. Embeddings, I am using CentOS transformers. I am using PyMu PDF, like PyPDF. It's not PyMu, it will be PyPDF. Okay, and then we have python.env for environment variables, and for typing and utilities we have pydantic for our proper modeling of our data, then request and logging. Okay, all those things. So we'll save this file. Okay, and to run this you have to run this command pip install -r requirements.txt. okay, I have already installed all libraries, so I won't be doing that, but for you need to install all. All right, so after that we need to have our .env file where we'll be keeping our Groq API key. So .env, here I'll name my Groq API key. Okay, now for you to get Groq API key, you can come into this Groq Cloud website, and here in this console.groq.com/keys, here you can have your API key. Okay, you can easily create, and the model that we'll be using is this one. Let me just show you. We'll be using this LLaMA3 70 billion parameter of 8192 model. Okay, all right, so that's being said, now we will create our main.py file. Right, so now we'll initialize our FastAPI backend. So we'll create a file as main.py. okay, and here I'll import FastAPI from FastAPI. So from FastAPI I'll import FastAPI. Okay, and after that to initialize app would be FastAPI. Let me just give it a name. So Chatbot 2.0. The title spelling is wrong. All right. Okay, and so after that we need to define some route. So @app dot, let's say a get route where the API endpoint will be /test. Okay, and then async def test. I'll simply return a simple message. So message would be testing successful. All right, now to run this application, I'll come over here. I'll write this command uvcorn gap main app reload, enter. You could see that my uvcorn is running on this by default port of 8000. Now to test it, we'll use Postman, and I'm doing that because this is this is how I generally create a backend. That first I try to test the minimal API endpoint to see that my routes are working, and then I'll be building the main application over it. Okay, so here you could see we have a Ragbot that I was testing. So I'll just create a new collection. All right, so here let's say I'll name it as Ragbot 2.0, not like this. So Ragbot 2.0. all right, so after that we'll create a new request, add request. We'll come into here, and here we need to paste this, this our URL. So I'll paste it over here /test. right, we don't need to pass any parameters, so we'll just click on send, and you could see testing successful. Okay, so our FastAPI backend is running successfully. Our API testing is done. Now we'll be creating our application on top of it. Okay, now we'll set up our logger.py, and this will help us to check all kind of warning information or any kind of debugging message that we might need to help for our deployment, for our development purpose. Okay, so logger.py, and we'll be using Python's built-in module like logging. Okay, so we'll import logging. All right, we'll create a function. Let's say setup logger. Okay, a normal function. Setup logger, and here we need to give it a name for our log file. So the name would be, let's say, Ragbot. Okay, then colon. All right, now here we'll define our log function. Now after that, finally we'll be calling our logger. So setup logger, here we'll call this. Okay, now let us create the function. Let us define the function. So first thing, we need to in a logger variable we'll be calling logging dot get logger, and we'll pass the name of our log file name, which is Ragbot. All right, then logger dot set level mean in what reason we want to use this log file. So we'll be using this for debugging purpose. Generally we'll use, so we'll use debug. Okay, now after that we need to create console handler. Console handler. Okay, so let's say in ch logging dot, I'll be using this stream handler function, and this will kind of help to show this logger, like all those log files, it will send it to my command line or my terminal. Okay, so ch, and we'll also need to set the level of this command line logger to debug. Okay, so again logging dot debug. Okay, after that we need to format our log file, like in which format you should see your log, all those log files data. Okay, so formatter, for the format, this is the basic format generally we use, like I use, not I won't say we. In logging dot, I'll call this formatter. Here there is a string. Now percent, I need to give the timestamp, right, like in which time we are seeing the log. So as ascending time in second, then space, I need to provide the name of the log, the kind of name of the log. So level name is, and percent. Alright, like it's make like this, and and then we need to pass the message, right? So percent, simply pass the message is. Alright, so in this format I'll be first showing the time, like timestamp, which kind of log, and the main log message. Alright, and then ch dot not format, I need to use set formatter, and I'll pass this formatter. Alright, okay, now after that we need to we need to add some line to kind of handle some duplicate loggers. Like sometimes what happens, you are setting your own logging, but Python inbuilt module is kind of providing their own logging, but sometimes this log messages could be same. So we need to make sure that one log message should be shown only once. So if not logger, if not logger has handlers, logger dot add. I mean, if the on the log file that this function would be generated, if that particular log file is not in the command line or not in the terminal, then and only it will add it to that log file. Like it will help me to reduce any kind of duplicate log files, simply like log messages. And after that, normally I'll simply return logger. Okay, and I've already called the function, right? Yes. So that's where my logger.py is done. Now I'll be showing you how to use this logger into your PDF handler, into a query handler, into your Vectorstore handling, all those kind of thing. Okay. Alright, so we'll create a module folders. So modules. Okay. Under this, the first file that we'll create is LLM.py, and this file where will be process our LLM chain, like how will kind of take response from an LLM and how we'll process the LLM to as per the model name. Okay, so LLM.py. All right, so first thing we need to import OS, and then from .env we'll import we'll need to import load.env to kind of retrieve environmental variables. Okay, all right, so after that, as we are using Groq, so from LangChain Groq we'll import Chatbot. Then from LangChain .chains we'll need to import retrieval QA to get our retrieval question answer. All right, now we'll call our load.env function to load all environmental variables. Now what we'll do, we'll simply, this is my Groq API key, would be os dot get env, not get env, actually we need to use os dot environ dot get. Here we'll have my Groq API keys. Okay, all right, so after that we need to create our function. So get LLM chain, right? And in this get LLM chain, here what will be passing, will be passing our vector store, cause first we'll be handling our PDFs to create those vectors, and we'll store them into our vector store. Then when user will give a query, it will get embed, and then those embedded query will get mapped with our vector store. Then LLM have to retrieve the relevant information from them. So we need to pass the vector store to this get LLM chain function. So as of now, I'll just say vector store. Okay, here I'll define my LLM chain. So LLM, I'll call chat Groq. Here Groq API key would be os dot parent dot get API key. Okay. All right, so I didn't need to kind of use this again, because we have already getting the environment keys from this line, but I don't need to write this like this. Okay, so here I'll be calling Groq API key. Okay, all right, after that I need to pass the model name, which would be in my case LLaMA3, as I said, 70B8192. all right, done. Then we need to define our retriever. Here will be retrieving data from our vector store. So vector store dot as retriever, use this search codes, and we want around 3 relevant sources to pick. Okay, so relevant source will be 3. After that, I'll need to kind of return this retrieval QA. All right, so this retrieval QA should be in block later. QA. This one should be also in block. Okay, so retrieval QA, and I need to change this as well. So retrieval QA, then dot from I'll be use chain type. Here I'll pass those parameters. So LLM would be LLM. My chain type would be stuff, and my retriever would be retriever, and return source document should be true. Okay, now save it. So this will help us to to kind of provide our vector stores to our LLM and to retrieve our information and to retrieve our 3 relevant source of information from our vector store as per the user's query. All right, now in our next module we'll be handling the PDF. So now we'll take care for the vector store loading part. Okay, so I'll create a new file as load vectorstore.py. all right, and here we need to import couple of things. So import OS, then from pathlib we import path to check our PDF's path, then from LangChain dot vector stores we need to import our vector store, which is Chroma. All right, and then we need to import from LangChain dot embeddings. We need to from embeddings we'll be importing Hugging Face embeddings. Okay, then from LangChain dot documents loaders. So document loaders will import PyPDF loaders. Okay, so PyPDF loader, and then the last one would be from LangChain dot textpeter. We need to import our recursive textpeter. Okay, so recursive character textpeter. All right, so now we'll be storing our embedded vectors of those PDFs into a directory called ChromaStore. So for that I'll be creating a persist directory, I mean that directory that exists. So slash ChromaStore. Okay, another directory that I'll create, which is upload dir, and this is to store in local all our uploaded directories PDFs. So uploaded PDFs. Okay, all right, now to create the upload directory, so os dot I'll use make dirs upload directory if exist okay is true. Okay, all right, so now we'll be creating the function that will handle our vector store. So def load Vectorstore. Okay, and we'll pass our uploaded files. So whatever files user will be uploaded, all those files will get come in here. Okay, now simple file paths will be initialize an empty list. Then for file we'll run a loop. So for file in all my uploaded files, what we'll do, we will simply save the path for each and every file. So save path upload dir slash file dot file name. Okay, all right, after that we'll be opening it. So with open save path, then need to write it. So wb, as we'll be editing those files, so then as if for an alias we'll write into this PDF files. So f dot write file dot we'll be reading each and every file, and we'll append them. We'll append, so file paths dot append str save path. So we'll append those each and every path of those uploaded PDF into my file paths empty list. Okay, that we have initialized before. After that we'll be having those docs. So for docs over here, for path in all my uploaded files, I have this save path where, oh, not this one. So for path in my not uploaded files actually. So as we have uploaded all the files, now we need to kind of loop through those uploaded files. So for path in file paths that we have uploaded already, file paths need to have this variable loader. Here we'll call this PyPDF loader function, and we'll simply pass the path. Okay, after that I need to extend my docs. So docs dot extend loader dot load. Okay, all right, after that we need to use our recursive character splitter to kind of split those PDFs into multiple chunks. Okay, so splitter, we'll call my recursive character splitter over here. Chunk size, I am taking 1000. You can change as per you wish. Chunk overlap, I'll be taking, let's say, 100. Okay, then text should be, I'll call this splitter dot split documents. Here I'll pass the docs. Okay, so text, everything's done. Okay, here. Alright, now after splitting into several chunks, we need to embed those chunks into vectors. So embeddings, here we'll call my Hugging Face embeddings. I need to pass the model name of that embedding function. So I'll be using all mini lm hyphen l12 hyphen small v2. Okay, you can use OpenAI's embedding if you want to use. Okay, All right, so after that we need to add this embedded vectors into those persist directory of ChromaStore. Okay, so if os dot path dot exists persist directory mean our ChromaStore, and os dot list directory our persist directory. I'll call a variable Vectorstore. So Vectorstore, here I'll call my chroma. Here I'll pass persist directory, which is in my case persist directory, this one, and embedding function is my embedding that I've created, embeddings. Okay, after that again in Vectorstore dot add documents function, I'll pass those texts, and finally Vectorstore dot I'll write persist else condition, else Vectorstore chroma dot from documents. Here I'll pass the documents, let's say texts, embeddings would be my embeddings, and persist directory would be this persist dir. Okay, done. Then simply I'll call my Vectorstore persist, so Vectorstore dot persist function. Finally I'll simply return my Vectorstore. Right, and I'll save it. So here is my Vectorstore done. Now we'll create those two files that will handle our PDF uploading, and how to process those user query and how to process LLM's response as per the query. Okay, all right, so now we'll handle our upload files. So I'll name it as PDF handlers.py. all right, I need to import a couple of things, so let's do it fast. Import OS, import shuttle, and as we are using FastAPI, so from FastAPI we'll simply import upload file, then import temp file. Okay, so upload directory, uploaded PDFs. Right, let me just check it again. Uploaded PDFs, upload directory, uploaded PDF. All right, same. Now let's get the function. So let def save uploaded files. All right, here we'll pass our files in the format of list, cause user might give us multiple files. So upload file onto list format of string. Okay, now here os make dirs upload directory exist, okay, would be true. Okay, then file path, let me create a blank file path. Then over here for file in files, we'll use this temporary path where use os dot path dot join, provide our upload directory and our file dot file name, upload directory comma file dot file name, it will be for temp path. So there will be indentation error, so file name, then with need to open them, so open temp path as we need to modify, so wb again same s as alias f, shuttle dot copy my file object in the format of file dot file f. Okay, then in the file paths I'll append a new temp path, then simply return all those file paths, right? So file like PDF handlers is done. Now after that we need to create query handlers.py. Okay, now here first need to import from logger use logger, then def let's say query chain, and we'll pass my LLM chain over here and my user input in the form of string, of course. Then we'll use a try catch block. Here I'll use my logger dot debug, let's say running the chain for input, and user input is here. Now result would be chain. I need to pass the query, so query would be my user input, right? Then after result we need to have the response from the LLM, so in response I'll write response would be result of result. Okay, and we also need to showcase user the sources from where we are getting the result. Okay, so to get the source we'll use this doc, we'll use this metadata, so doc.metadata, and we'll use this get function where we'll use simply our source, all the source that we're having, so source and blank, then loop through all the doc in result of source documents. Okay, and after that logger dot debug chain response would be response. Okay, then return the response. All right, now as we are using try catch, we need to use except we'll be using one exception as e, and again here we'll use this logger dot exception, we'll write a message, error, query chain, to understand key exactly where do we have my error. Then we'll simply raise it. Okay, simply save. So now we have our LLaMA.py, load vector store, PDF handlers, query handlers. Now we need to build our main.py, where we need to kind of define each and every API route. Alright, so now we'll define our main.py, which will be the entry point for our FastAPI backend. Alright, so we have imported from FastAPI, we have imported FastAPI. So here we need to import our upload file, our file, form and request, as we'll be sending request to our backend, right? Then from FastAPI dot responses, we need to import our JSON response. Then from FastAPI dot middleware dot codes, we need to import our codes middleware. Then from typing we need to import our list. Then from the modules that we have built, so modules dot we have load vector, so load vector, we need to import load Vectorstore. Then from modules dot LLM, it will be modules dot LLM, we need to import get LLaMA3. Then modules dot query handlers, we need to import query chain. Then from logger, import logger. Alright, and we have already defined our app FastAPI. That's all right. After that, we need to allow our all front-end origin, and this is a kind of a best practice for using FastAPI backend, because you might need to change your front-end into multiple APIs, right? Into multiple URLs. So it's always better to allow course origin for every URL. So app will be doing this, allow front-end. Okay, so app dot add underscore middleware, will pass our course middleware. Then we'll use allow origins of star. Then will be to do credentials. Okay, and we need to allow methods. All right, and after that we need to kind of allow our headers. Okay, it's done. Now as we are using our FastAPI, so we need to make sure that we need to have a solid middleware, like so app dot middleware, as we'll be using HTTP, not this here, async def catch exception middleware. Okay, so request would be my request and call next. So these are the parameters that we'll be sending to my catch exception middleware. And here in this try catch block, will first will be returning await call next our request, and as for try for our exception as exe logger dot exception, it would be unhandled exception. Okay, so the exception that our logging hasn't been handled, this middleware HTTP would handle those things. Okay, then return the JSON response of it. So JSON response with a status code of 500 because it will be for error. So 500 content provide error with str.exe. all right, so our middleware is done. Now we need to define our route. Okay, so we'll be having two routes, one for upload PDF and one for asking any queries. So for first app dot, it will be a post route. So app dot post slash upload upload PDFs slash. Okay, and we'll be having another route which will be app dot post ask slash. Right, so for this upload PDF route, we'll define a function async def upload PDFs. all right, upload PDFs, where we'll pass our files with the list of all our files, list of upload files. Okay, and we'll keep that in our file. Okay, all right, so upload PDFs. Now in our try block, we'll use our logger dot info received len files and files. Right, then we'll simply load vectors. So load Vectorstore, where we'll pass our files, and then we'll again get a logger information, logger info that documents added to Chroma. all right, then we'll simply return message, which would be Vectorstore updated. Okay, and for our exception as here we'll again use a logger dot exception. We'll having a simple error during PDF upload. Right, so after that we need to return a response. So JSON response, where status code could be of course 500 for error, and for the content part we need to provide error str a simple or error. Okay, all right, now for ask, for this route we'll again create a function async def and ask questions. So ask question where we'll pass our all the question in the format of string. Okay, in the format of string, and then again we'll in our try we'll use our logger. So here we'll use our logger. First logger.info to see what kind of task we are doing over here. So user query. Okay, all right, this quotation should be finished here, and we need to pass our user question. Okay, we got our question. So logger info done. Then I can simply import a couple of things over here. So from LangChain .Vectorstores, import chroma, and from LangChain .embeddings, Hugging Face embeddings, and from modules load Vectorstore, will import our persist directory. Alright, so after user ask a particular query, we'll be embedding that when we'll add that into our Vectorstore. Okay, so Vectorstore p, call the chroma. Under here we'll pass a couple of things like persist directory, which is of course persist for. Then embedding function would be our Hugging Face embeddings, where we need to provide our model name. So technically model name, which of course will be same, that all hyphen mini lm l2 v2. So it will be l12. Okay, so our embedding function is done. Now after that we'll put that through our chain. So chain will call our get LLM. So get LLM chain. Here we'll pass our Vectorstore, and we'll store the result into this result variable by calling our query chain, where we'll pass my chain and the given question. Right, alright, so results question is done. Now logger.info, we'll write if the query been successful, we'll write query successful. Okay, then simply return the result. Okay, then except exception as e, will use logger dot exception, where we'll pass error processing question. Okay, and then again we need to showcase our status code. So JSON response, our status code, which would be around 500. Okay, and for the content, error with str e. Error with str e. All right. Yes, now we'll save it. Now our main.py is done, and we can easily test our all API routes. Okay. Alright, so now we'll test our application. So this is the command ubicon main app reload. Okay, you could see it has built this uploaded pdfs folder in my server folder. Okay, now we'll just simply, and this is all those logs that we have done. We'll copy this URL. I'll come to my Postman. I'll create a new request over here. Okay, I'll name it as upload PDF. I'll change it to post. I'll paste it over here. I'll slash, let's say, uploaded. Upload PDFs slash. Okay, now to give it, we'll come into this header and we'll save it first. Save. Okay, so we'll come into this header and this header, body from data, actually for this, so we'll come into this body and we'll select this form data. Okay, and in this key we'll select files. Okay, and here we'll select file. Okay, and here from this select file we have to upload some PDF. So I'll upload this file. Okay, all right, now what I'll do, I'll simply run on this send, and let's see what we will be getting. If it's run successfully, it should create a ChromaStore folder in my server folder, and it should show me that my Vectorstore has been updated, and like this kind of message. Okay, so let us wait a bit. Let us see our log files. All right, you could see over here it is saying this thing, embeddings, received 1 files. All right, it's saying internal error, token, your token, logging, Hugging Face login in the with a private repository, make sure. All right, so it's saying some error. So all mini LM L1 to V2. Asha, you could see that my model name is wrong over here. Okay, so I need to change this. So this is okay, mini LM, but if I come into my load Vectorstore, here you could see I have written a wrong name. So I'll save it. It has run again, and now let's see. I'll run this again, send, and now I should get the response properly. Okay, trace the log file as well. All mini LM L12 V2. Okay, all right, you could see files processed and Vectorstore requested, Vectorstore updated, and this was the message that we should have got when our process has been success. You could see return message, file processed and Vectorstore updated when it is been done completely properly. Now we'll see this ask route. Okay, I'll come over here. I'll do a duplicate of this. Okay, I'll write it as query. I'll simply change this to ask. Okay, now again body from data, here I'll write as question, and my value should be, and here in this value I need to ask something about the PDF. So my PDF is my resume. Okay, so I'll ask some question about the resume. So what is in my resume? I have my college name. So what is the name of the okay, now let us precisely. So what is MCKV? Let us see what is giving. It's some tricky question. Again, it's error. Mini LM sentence transformer local folder is not valid model identifier. Again, I've done some bad mistake over here. So you know, the name should have been all, right? I've given it AKK, so let it make it L. So Control S. Now we'll come to my Postman. I'll send it. Now I should get the response now, and let's see what response it would be. Trace it first, you know. Embedding models name all minute LM L1 to V2. All right, here you could see we got the response. MCKV stands for, it's wrong. Mahesh Sri Chandra Kanti Vidyayatan is wrong. What is the educational institution? Okay, so this is the thing, you know, MCKV Institute of Engineering is a college where the person mentioned in the resume is pursuing their BTech degree in computer science with AIML. Okay, and the resources are supratimnak.pdf, this particular PDF. Okay, so I don't know why it's given me this some unknown name of Mahesh Sri Chandra Kanti. Okay, so there's some glitch that you might fix by giving some proper prompt. Alright, so now as we have tested our backend, so now we'll get to our front end. Okay, alright, so now for the front end we have get into our client folder. Okay, and let's get a client folder. I have deleted that folder. So client. Okay, inside this I'll create a folder named config.py where I'll simply just store my API URL. Okay, alright, so we have our backend URL API endpoint, which is localhost 8000. Now let's create our app.py, which will be the entry point. Okay, here we'll import Streamlit as st, and let's keep it blank. Then st dot set page config. Okay, page title, I'll name it as Chatbot 2.0. Okay, and layout I'm making it, let's say, wide. Okay, then st dot title PDF chatbot, yep, PDF chatbot, let's say rack PDF chatbot. Okay, now we'll just simply call the three function over here. Okay, so render uploader, this will help us to upload our PDF files. Then render our chat to kind of showcase our chat. Okay, then render history download to download our conversation history. Now we'll build these functions in a format of a module. So we'll create a components folder over here, components, and before that we need to kind of export our backend API endpoints. So for that, I'll be creating a folder as utils. Okay, under utils, I'll create a file as api.py. Okay, and here I'll simply export my API points. So import requests from config, import API URL, then def upload PDFs API. Okay, we send the files as the key. So files payload equals to would be files and fname fread function f.name f.read with application type would be application JSON. So application PDF, sorry, not JSON, application PDF, f.name application PDF, and for f in all the files. Okay, all right. So then we'll simply return request dot post f string our API URL, then slash our API point would be upload PDFs slash, right? Then simply files would be files payload. Okay, this one is done. Now for def ask question, here we need to pass question and we'll simply return. Let us copy this and we'll paste it over here. So request.post, we need to change this name to ask, and in place of files payload, we need to provide data where question would be question. All right, so we have exported our all backend APIs over here. Now we need to create this component. So a couple of component would be our upload.py. Okay, then let's say we have history download.py, right? And then of course our chat UI UI.py. Right, so first let's create our upload, like how we'll upload our PDFs. Okay, so to upload, right, so let us first import Streamlit as ht, then from utils.api we will need to import what? Upload PDFs API. Okay, then def render upload. What's the function that we have written over here? app.py render uploader, right? So render uploader. Okay, here I will simply write and I'll keep that in my sidebar. So ht.sidebar dot header, let us give a simple header, upload PDFs. Okay, all right, after that in my uploaded files, I keep ht dot sidebar dot file uploader. Here I'll write upload multiple PDFs. Okay, then for the type we'll be keeping it not like this. In type would be simple, it would be our PDF. Okay, and as we need to accept multiple files, so accept multiple files would be true. Okay, so after that, if ht dot sidebar dot button upload to DB and uploaded files, then here in response we'll call our upload PDFs API and we'll pass our uploaded files. Okay, uploaded files. Then if response dot status code is 200, mean our API has been worked properly, then ht dot sidebar dot I need to show a success that successfully, right? All right, and then for our else ht dot sidebar dot error f string error would be what? Response dot text. Okay, I'll save this. So our render template is done, and I'll come into my app.py and I'll simply write from components dot from upload render uploader. Okay, so one is done. Now history download py. Okay, it will be a pretty simple module. So again we need to kind of import our Streamlit as ht, then def history download. Okay, here if ht dot session is there, session state, then we'll get all the messages that's been conversation happening. Okay, and in our chat text /n dot join, I'll create a txt file. So then in upper function content, it will finish it should finish over here. So if string m with role dot upper function that we'll be using with m content and here for m in ht dot session state dot messages. So this one should finish. Right, so this should finish over here, and this should finish over here. Okay, it's done. So chat text, then ht download button. Here I'll write key here, you can download chat history with, you have to provide the chat text, and file name would be kind of .txt. Okay, then for MIME, let's make it text/plain. All right, my rendered history download is done. Now I'll just come over here, I'll import this from components dot history download render. All right, so for the chat UI component, I'll paste the code. You could see that we have simply called our utils.api, we have called our ask question API export from this. You could see ask question API. So chat UI, we have first created a session state. We are rendering our existing chat history. Then we are taking our input and responses from our as a user, and we are showing the user input. Then we are processing our responses. Then we are processing our question. We are sending that to our API, this ask question. Then we are processing the responses, and we are showing that as an assistant content. Okay, I'll be saving that. I'll run the front-end application. So Streamlit run app.py, I'll run it. All right, okay, so Streamlit run app.py. Okay, so here you could see we have our RAG PDF chatbot, RAGbot 2.0. Here let us browse some files. This thing, open, upload to DB, and we should see some success message over here. Let us wait. All right, so you could see we have gotten this, we have got this success message of uploaded successfully. Okay, now this PDF is one of my internship certificate, so I'll just write a function. Okay, I'll just give a query about that. So let's say what is the PDF about, right? Let's see what PDF is going to give me as an answer. So what is the PDF about? You could see the PDF appears to be a resume or a curriculum vitae of a fourth-year BA student specializing or thing. It's not taking from this PDF, it's taking from a previous PDF. Okay, so this PDF consists of the certificate. So let us ask something related to that. So what type of certificate is this? Okay, so let us see. You could see this is an intensive certificate from this one. Okay, provider, and all right, you could see the name of certificate provider is Exposys Data Labs. All right, so you can ask this kind of more precise questions. All right, so yeah, that's been done. This was for this video. We have created this RAG PDF chatbot with FastAPI backend and Streamlit frontend with kind of a microservice architecture where we have a different front end and we have a different back end, and we are connecting that through a cross origin API. All right, so yeah, that's for this video, and thanks for watching.